Hello everyone, welcome to MS Study Pros. Today we're going to be looking at 3 of the hardest SAT math problems that you will run into, specifically area and volume type problems. These are common to appear on the section 2 of the math, and sometimes these can just look impossible, but once you start grasping the concepts, they get a lot easier. Alright, first problem here. If you want, you can pause and see if you can work this out on your own. Okay, if square A has an area 16 times greater than square B, what factor bigger are the side length of square A compared to square B? So it's talking about squares, talking about side lengths. In a situation like this, I like to just run my own little test run. So what I mean by that is assigning values and seeing how it actually works when you plug in real numbers. So here I have two squares, one with an area of A and one with an area of 16A. So let's plug in the side length and use it for this small square. Let's just use 3. So 3 times 3, that's 9. So the small one has an area of 9. So now what I'm going to do is take 9 times it by 16. And that gets you 144. So now our new square has an area of 144. If the area of the big square now has an area of 144, we can just take the square root to find the side length and get a side length of 12. So we assigned a side length of 3 to this one, and a side length of 12 is what we found for that one. So how many times bigger is 12 than 3? It's 4. So the answer to this question is 4. And I did that by plugging in some fake numbers and just seeing how it would actually work. Alright, here's a second type of problem. You guys can pause here if you want to solve it by yourself. Okay, a right circular cylinder has a surface area of 32 pi units squared. If the circumference of the base is 4 pi units, what is the height of your cylinder in units? So if we know the circumference of the base is 4 pi units, we can use this to solve the r, because we know circumference equals 2 pi r. And if the circumference is 4 pi, it equals 2 pi r. Divide out on both sides, and we get the radius is equal to 2. Now the surface area of this circular cylinder is 32 pi. Now the surface area of this circular cylinder is the area of the base plus the area of the middle part plus the area of the base at the bottom. We can do this, so we can plug in 2 times pi r squared plus the area of this middle band, which is the circumference times the height. And we know that the r is 2, and then we can sub this into Desmos and see what it gives us for h. And instead of h, we will put x so that Desmos will accept it, and we can see that x equals 6, which is the height. So the height of the cylinder equals 6 units. Are you still with me here? We're on to the last problem. I'll let you guys pause and see if you guys can solve this on your own. Okay, a right cone is made such that the height is 3 units longer than the radius of the base. Which of the following expressions correctly displays that relationship where v is volume and r is radius? So we know the volume of a right cone is v equals 1/3 pi r squared times h. So we can plug that in here. And remember, we said that the height is 3 units longer than the radius, so instead of h, I'm going to put r plus 3. And now I'm going to distribute this times the r out and times the 3 out. Okay, here we go. And I'm instantly seeing that this 3 and 1/3 cancel out. And I'm seeing that this r will distribute here to become r cubed. And after that, I can't simplify this anymore. So we're going to go see if this is one of the options. Originally, I had the options cropped out, but here they are. And as you can see, this option matches problem B, which is the correct answer. Alright, thank you guys for watching and sticking all the way through. I hope this helped learn 3 of the hardest types of math SAT area and volume problems.